Okay, so I think the part that's hard is that you're using only recursive formulas, and I'm not sure how long your teacher wants you to do that. I'm going to just show you another formula that makes things easier, but I have to be honest, it depends on what your teacher wants you to do. But I want you to look at, let's start here with arithmetic, and we can kind of talk about geometric too. But in the arithmetic function, right, you understand clearly from your work that all it does is add on each term. So for example, if we had like 3 and we added 5 each time, right, this is what we would get, right? Sorry. And you understand that that means that at any moment, right, whatever the term is, right, you just add 5 to it. So you might say that whatever the term is, that any term you want, you're going to take the one before it, and in this case, you're going to add 5, right? Which means if you wanted to know, if you were on this term and you wanted to know 2 terms, you would add 5 twice. Makes sense? So at any point, you could use this by saying, hey, if we just take the first term, add our difference, right, and multiply it by 1 less time, right? Does that make sense? Then the formula becomes really easy. Geometrically, when we multiply, it's also pretty straightforward. So I'll do this in blue, right? If I just multiplied by 2 each time, right? If I start at this should be a 1. My first term, right? And I multiply by 2, I get the second term. If I multiply by 2 twice, I get the third term, right? So, et cetera, et cetera. So you're going to multiply, in this case, by 2, 1 less time than the term you're looking for. So let's do an example from your homework. I do want to go back to these formulas. Your teacher should give them to you here pretty soon, but they're just a nice way of figuring out sequences when you have more unknowns. Let me know if you have any questions about this. Okay, so here's this bathtub problem, right? So if the drain is closed, right, you have 20 gallons of water. So what we know is that the first term is 20, right? And what we know in this case is that our D is 2.4, right? You can write a recursive formula for that, right? U to the n is equal to the U to the n minus 1 plus 2.4, right? So really what you're going to do is you're going to see how many times you have to add 2.4 in order to get to 50, right? Does that make sense? That's really all you're going to do. So we're going to do 50 is equal to, in this case, 20 plus 2.4, and we're not sure how many times we want to add it, right? So you can go ahead and solve this equation pretty easily. I'm going to let you do some solving, but I will also solve. So when you do this, n minus 1 is equal to 12.5, so it's going to be at about 13 and a half minutes, right, is when you're going to get up to 50. Make sense? In the second one, right, in this problem right here, B, there's water going in at 2.4 and coming out at 3.1, which means overall you're losing half a gallon a minute. So in this case, we'll do this in green, I guess. We're still starting with U1 is 20, but in this case your D is negative 0.5. And so you're going to do the same equation, except for you want to get to 0, right? So we can do that down here. So 0 is equal to 20, and then how many times are you going to have to subtract 0.5, right? And whatever that is, it's 1 less than the minute, right? And I'm going to let you go ahead and solve that equation, right? And then given this information, you can write the recursive formula. Okay?